Hello guys, welcome back to another video. I am Rajat and today we will be solving another LeetCode question. Uh, and it's the question of the day. The question number is 2523 closest prime number in range. Okay, it's a medium level question. Let's see what the question says. Given two positive integers left and right, find the two integers num1 and num2 such that num1 and num2 are in the range of left and right, both included. Both num1 and num2 are prime numbers. Num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. Okay. Return the positive integer array answer num1 num2 such that there are multiple pairs satisfying these conditions. Okay. Return the one with the smallest num1 value if no such number exists. Return -1 to -1. Okay, fine. So let's go to our paint and let's solve the problem. Okay, so we are given with two numbers. Just a minute. We're just given with two numbers, left and right. This is too much. Yeah. Okay. Left and right. So let's call this L and this is right. So what we need to do here is that we have to find all the primes p1, p p2, p3, p4 and dot up to pn. We have r. Okay, so now given that we have to find both the numbers in such a way that p2 minus p1 would be minimum. Okay, so for that, just a minute, let me just adjust my pen tab. Yeah, that way. Okay, so we have to find in such a way that this condition holds. So for that, suppose, so one thing is for sure that that uh, yeah, if we subtract, oh shit, if we do p3 minus p1, that will always be greater than p2 minus p1. So for any condition we have to only check for n minus 1, we always have to check like pn with pn minus 1, and out of all those values we have to just find the minimum. Okay, so this is the main key idea. Let me just summarize it again since I was struggling with okay, we are given L and out in that range we have P2, P3, P4, P5 and dot up to Pn, and we have R. Now given that PR both are inclusive, so L could be a prime number and R could be a prime number, so there's not denying that. Okay, so the first observation that we can do is that we have to, after finding all the prime numbers, we have to just do Pn minus Pn minus 1. Okay, that's the first observation, because if we do, take another pen, if we do Pn minus Pn minus 2, that's difference would be definitely greater than Pn minus Pn minus 1. Okay, That was always the case. So we don't want this, this, rather we want this. So for seeing that, we will always check for this. Now if there are n prime numbers, okay, n prime numbers, then we will have such n minus 1 matches. Okay, since n minus 1 matches. Okay, so we will run a loop. Suppose we hold all the prime numbers in the list or in the given range, and then we find out. Now so we just have to find the minimum of all of them. Okay, minimum of p2 minus p1, and we have to return it. Okay, now how we are going to do it? So the best way would be a map where we store the difference first, then we store pair of int and int. Okay, in this way we could just sum of all, try to minimize all the difference, and out of all that difference we will just find out the pair which represents p2 and p1. That could be the case. So that could be the case. So my intuition says this. So let's find out in that code. So first let's code it. So first of all, let's write a statement on how to find a prime number. Okay, I may have to just summarize how you do it. Okay, do it. Suppose okay, let me just do it here only. All you have to do here is that you take another pen. Okay, what do we have to do? We know that any integer, suppose I, is greater than equals to 1, it's not a prime. Okay, if I is equal to 2, then it's a prime, and for starting from 3, okay, let me just, yeah. So if we have I less than equals to 1, then it's not a prime. If I equals to 2, it's a prime. If I is divisible by 2, then it's not a prime. Then from 3 onwards, we'll just check for 3 to a square root of I. If any number is divisible by I is divisible by any of the number from the range 3 to square root of I, then it's not a prime. Otherwise it's a prime. So this is the algorithm. Let's write it down. So let's bool is prime int n. Let me just switch on the fan. It might give some more noise. Sorry for that. But I think I'm audible enough. Okay, audible enough. So first of all, if n is equal to 1, return false. If n is close to 2, then return true. if n is 2, then false. Okay. Now for int I equal to 3, I is less than square root of n. Then we only have to check with uh, the the odd numbers only. If n I equal to 0, return false. Okay. Otherwise, you don't have to. Then you can just return. That is the smallest and efficient way of deciding whether it's a prime or not. Okay. Now, let's see. Vector int primes. Okay. First of all, it will use the number of primes in all the primes in the range of left to right. So for int I equal to left is less than equals to right, I plus plus. If is prime I, then primes dot push back I. Yeah, that's it. That's it. Now we have to create and so how we will do it? Let's instead of doing this map function, I have another better idea. We have to return a vector, right? Vector of int answer to 0. Both are it's a size of 2 and both the spaces are initialized to 0. Okay. Now what we will do is that for int I is equal to 0, for int to have yeah, we can have, and let's have int max in distance. Let it be int. Okay, suppose we are going with equal to 0 is less than times dot size I plus plus. We have to go with connection so that we can check if auto difference has to be times I plus 1 minus times I. Okay. We are making this is P2, this is P2 and this is P1. Okay, so we are both subtracting it. If difference is greater than difference or equals to difference, right? Both equals to difference, then what we will do is first if and the second step would be, let's just change this to -, and the second step would be the monumental. So, answer 0 would be equals to primes I, and answer 1 would be equals to primes I plus A. Okay, so in that way you could have this, and let's return answer. Okay, simple and short. Okay, output is 17 and 19. Sense. Okay, what we can do here is that we could take minimum of answer 0 in primes, and here also we will have minimum of answer 1 primes. Yeah. This as satisfying this condition, we actually forgot about this condition. So let's go with it. See, why is it? Why is it so? So 2 x minus 1 minus 1 is perfect. Okay. Instead of prime, let me just return primes. Okay, let me find how many primes are there. 11, 13, 17, and 19. Okay. That's perfect. Okay. Instead of doing this, let us just change it to primes dot salaries this one. Okay, greater than equals to 0. See, I minus index. Okay, that will first access I minus 1. Okay. Difference, then will be minus 1 and simply I. And this should work, I suppose. Okay, both are failing. Great. Okay, we actually turn primes. I have to return answer. I forgot to modify that code. Minus 1, okay, greater than 0, I minus minus. Out of the frames has 3 primes. We are starting from the last, subtracting with each number, the previous number, and if the minimum difference is greater than difference, equal to difference, minimum difference is greater than. Minimum difference is greater than, yeah, right. Minimum difference is greater than difference, then we change minimum difference to current difference and answer to times I minus 1 always. Okay. This has to work, but I'm not sure why. I will leave it right now. So difference between it's not even going to context. Not even checking this one. Three values 11, 13, 17, 19. We have this and we should have. Let me just have. Let's just debug this code. Let's dot push back. Okay. Let me return it here. Let's see what the code says. I have 2, then 4, then 2. Yes, it's perfect. This is how it's supposed to be. Isn't it? This is how it's supposed to be. We can make this. This and then this and this, and then we make it. So one thing is for sure that our code is working good, but I am not sure why isn't getting into this. Should we check the solutions? Oh, come on, man. It should get updated at least once. At least once. So, assuming it's not even going into this. Can we do any debug code here? If possible. If possible that we could debug the code here, no. No. Okay, let's just debug. Okay. This is prime size minus 1. This is actually 19. Then 19, then minus. And the auto difference would be 19 minus 17. That's 2. Is minimum difference, because int max, is greater than difference. Yes, it's greater than difference. It's much greater than difference. Then it should be minimum difference has to be difference. So minimum difference has been converted to 3 now. Okay. Yeah. And answer looks okay. Let's check the solution of the this impossible. Okay. This is where I need to fall. This one. Gap. Okay, why we are feeling at this section? Why so? Why you are feeling in this section? Let alone. It is saying that. Okay, let me just change the yeah, one, and I just done times dot size with plus I. Okay, and auto difference is it's I minus one. Okay, that's good. If in gap, if then difference. My code was almost similar, but I don't know why it's failing. Okay, that's true. And the result is times I minus 1 I. What if for 1130 don't fall into this thing? Will it fall? It should not fall, right? Because if isn't, come on man, ये कैसे हो सकता है? Like पहले जब मैंने किया तो 11 और 13 आया, नहीं आया उसमें, it failed, but now it's working. अगर मैं यहाँ पर इक्वल्स टू डाल देता हूँ, okay? तो okay, since since it's starting from the very beginning, तो उसमें ऑलरेडी 11 और 12 रह जाता है, 11 और 13 रह जाता है, और वो फ्यूचर में कभी अपडेट होता ही नहीं है. यस यस इट दिस has to work. This is good. ओके, हमने बस एक छोटा सा इस इधर उधर कुछ किया था एंड बोला that's great. Yeah, so that's it for today. We write a good code. Yeah, thanks for watching. Please like, share, and subscribe. Bye bye.